Alright everybody, here we are. By the way, let's continue. And yesterday I learned about WebRTC at night, and then I was supposed to be live during the night. I mean, I was supposed to be awake. Then something happened and that got cancelled. Then I said, let's sleep, have a proper sleep at night, and then work during the day and all. This is how it's gonna be going on. So without any further delay, let's simply continue. First of all, I will be understanding about WebRTC, exactly the theoretical things, how the things actually work and all. So, and after that I will just simply go ahead. So without any further delay, ladies and gentlemen, let's get started. First of all, the notes that I actually made, they've been even pretty crazy. First of all, the chats are gonna be off for sure. Let me make sure I'm audible. Yeah. So the notes that I actually made for the WebRTC, that's been pretty much crazy actually. I will be going through each and everything, and let's see how it's gonna be actually going on. So first of all, I learned about adding the camera now, and this has been pretty easy, right? You just need to have a video tag. Once you have the video tag, then you have to just simply stream. Not only that, from the navigator there is going to be media devices object, and from there you will get user media method. Using that you will be able to select a particular media. If you don't select a media, if you just simply saying that video is gonna be true, that means by default that media is going to be selected. If you are actually giving the device ID, so that particular device is going to be selected. So it is like you can select whichever device you want. Just after that, once you got the device, then you will get the stream, and you will be able to just stream using the source object. So it will just simply be streaming to that particular video, as simple as that. Autoplay is going to be on. So if you actually have a look over here, so this autoplay is already, this property is already here. That simply means that as soon as the stream reaches the video tag, it will auto streamed, auto played. It's just like that. Not only that, apart from that particular thing over here, we have something called get videos IDs, because of course if you have to actually make sure that a particular video device gets selected, so you will have to get the video IDs, and then you will have to select. So on the basis of these things, I will be able to get the ID, and that will be selected. Again, using the UI can actually be a lot better, but the main focus is not gonna be on that. So this was the overall thing, especially in navigator. You get media devices. Inside media devices you get remaining methods, I must say. One of them is the get user media. Another one is enumerator devices. Get user media will mainly give you the like users media, exactly how many medias are there. There could be audio media, there could be video media, and you will be able to select even the devices, not based on the device ID. Device ID is automatically generated by the browser itself. So if you are on any browser, you will be able to get the device ID. Keep in mind that that particular device ID will be different for different browsers. So the browsers actually create the device IDs on their own, and they will definitely be different. It's just like that. So let's go ahead, and next thing that I can actually do, that's gonna be, come on, it's cold. Just a sec. Yeah, it's fine now. So once this thing is done, then I learned about IP address and all. IP address gets really important, especially when it comes to especially when it comes to getting sending the video file, and especially even receiving a video stream. That gets extremely important. In that case, inside net I will have just this code /code, just this, and just a sec. Why are you even sending me this? Already, let me even just open it. No, let's continue. So every device, yeah, this is, sorry, this is gonna be a bit crazy, but yeah, I need to go through the documentation first of all. Okay, let's continue. And the first thing is gonna be every device on the web has to have an identity, IP address. The thing is pretty simple. Like there are two devices and you need to connect. So first of all, you need to make a video call. That simply means that there should be public IP address for that particular. There should be a router, right? First of all, and router will have its own public address. and then the router will then your device will have its own private address. So it's like router will have the public address, your device will have a private address. They will be connected, I mean there will be net, and then net will simply map the private address to the public address and all, and this is how things are gonna be going ahead. Let's simply go through it. Every device on the web has to have an identity card, identity IP address. Just a second. Alright, so let's continue. So mainly I gotta learn about net, and I will be taking the help of AI as well to just know it better. Every device on the web has to have an identity IP address. Net allows IP address sharing. Net allows IP address sharing. Many devices on the LAN can share one global WAN. LAN in the sense local address network? No, I don't even know the full form of this. Crazy. LAN full form. Local area network. So let's even do one thing. So net, every device on the web has to have its an identity card. That is right. Net allows IP address sharing. IP address sharing. IP address sharing. Many devices on the LAN. LAN in the sense local area network can share a WAN global. Like, now what is the full form of WAN? I think world area network. I don't know. Wide area network. Okay. So this is gonna be global for sure, and that's gonna be wide area network. This is actually gonna be global. Things are hard actually for me right now, so it's okay. Let's continue. So net allows IP address sharing. Many devices on LAN local area network can share one WAN wide area network. So there can be many devices on the local network, and there can be a global network. So you will be able to get your global network, especially if you want to get the global network. So you can search what is my IP address, and then you will be able to get your global address. So if I actually just click on this, so it's simply checking right now, and this is my global address. And if I talk about my local address, so that actually starts with 192. So my devices, all the devices, they are actually able to use this particular global address. This particular global address, and they have their own private addresses and all. It is just like that. Okay, so in that case I can just simply go ahead. Net is primarily implemented by routers. Net is primarily implemented by routers. Net is primarily, so router will have its own public address, and what, let's see, it will just map all the private address to the public addresses. Like this works between the private addresses and router. That means public address. Your router will create a table. Okay, your router will create actually. So your router will create a table that maps all active connections between internal private IP addresses and their corresponding external public addresses. There can be only one public address. That's the thing. So how can even this work? Let's see. This is gonna be in the red mark. I'll be knowing more about it, and then let's continue from here. Then there are types. There are three types: static, dynamic, and pad. These are the types of these are the types of net. So types of net, if I'm not wrong, I'm not even sure. So let's see, I will be going through it. Problem solution. Problem is gonna be simple. Individual computers may not have unique IP addresses. That is right. Unique IP address. Okay, so device IP addresses can change when moving between network or due to net changes. What is the solution? I servers are the solutions. This is kind of the most important thing. Every unique network connection which includes WebRTC is identified by a 5 tuple which consists of 5 specific parameters that collectively provide a distinct identifier for that connection. So ultimately, if you want to make a WebRTC connection, so you need to have these 5 things over here. Source IP address, this is the IP address of your device, the device initiating the WebRTC. So you need a WebRTC connection. For example, this info may contain both your public IP address and a private IP address. So private IP address in the sense, okay, so it will just simply do this this way. You got the private IP address of your device, you got the public IP address of the router and all, then you will send both of them. And not only that, then you got destination IP address, and this will again contain both. So this is the IP address of the WebRTC device you intended to connect with. This may contain both their public IP addresses and their IP addresses, etc. Source port number, this is a port number that your browser has allocated to your PC for the WebRTC connection, which is typically a dynamically assigned ephemeral port. It can dynamically be assigned from this particular range to this particular range. Destination port number, this is the port number on the destination device that you are wanting to establish a connection with. For HTTP, this will be port 80 or 443, but for WebRTC, this will be the other user's private port number. So whatever user's port number is, it will be that. Transport protocol, that can be UDP or TCP. So this indicates a protocol used for communication. WebRTC uses either TCP, transmission control protocol, or UDP, user datagram protocol. Each ICE, okay, let's see what exactly this ICE do. So each ICE candidate is assigned a priority value, which is a number ranging from 1 to this. A higher value indicates a more desirable candidate for establishing a connection. The browser's ICE agent is responsible for setting these priority values. The browser's ICE agent. So actually browser has something called ICE framework. That ICE framework has ICE agents, and they just do the job. So ICE agent is responsible for setting these priority values according to the ICE specification outlined by this IETF and all. So let's not worry about that. Then there is something called ICE framework that is again on the browser itself, and that ICE frame actually identifies the candidates. Candidates is going to be the best route in the sense either the route is gonna be using the TCP protocol, and there's gonna be IP address and port, and then there's gonna be the private IP address, and there's gonna be the port number, and then router will have its own public address, and all these things are gonna be sent. Or it will identify, okay, let's use UDP, and that can be candidate too. So it will just simply identify the things and all based on the receiver's description and all. I will be even talking about that. By the way, this is how it just works over here as well. Lastly, if you are just in the same network, this is called stun. Stun will be used over here in this particular level when you are actually using TCP or UDP, and you are trying to connect it to the remote device, and but when you are trying to connect your local device just inside the same network, at that time again your agent or ICE framework will simply decide a candidate. It will decide whether you have to use UDP or not. It will even check get the port number, it will get the IP address, this is the private IP address, and then you don't need a public address over here because the another device, maybe your laptop, is just in the same network, so you can just simply talk to that. So it is just like that. And by the way, this candidate should be the candidate's priority should be highest in the sense mostly host priority is higher than the stun, so that is how it simply works. And the priority is given by the stun only. So here there are ICE agents actually, and they are responsible for giving the priority and all. So this is how things are gonna be going ahead. I thought actually I needed to just go through the document, take the help of AI, but I mean it's understandable, so I don't even need to do that. types. Let's figure out the types of net. So types of net. Okay, let's types of network address translation. So net stands for network address translation, and there are three types. There is static type, there is dynamic type, there is PAT, port address translation. To be honest, don't really have much knowledge about it, but right now I will not be worried about it. I will be knowing whenever it gets important. I mean, I think by using them I will learn more rather than just simply knowing the definition and all, but I will be digging deeper. Types of net. Net in the sense what? Network address translation, that I have already mentioned over here. After that I have different types of net, like one of them is what static net, dynamic net, and PAT, a port address translation. So this PAT that I actually have over here, this is the thing that I'm talking about. So it simply means that port address translation, just like this. Dynamic, that's again gonna be net, so don't worry about that. Dynamic net, and that's gonna be static net. Alrighty, by the way, let's continue. By the way, as for this one, your router will create a table that will map all the active connections. Okay, it will do that, so I don't even need to worry about it. Things are understandable right now. Ultimately, router will map the private address to the public address so that we can actually get them. So it's gonna be kind of creating a table so that I can get my private address as well as the public address. So alrighty, let's continue, and that is it. Alrighty, by the way, let's go through the ICE framework. Once I've got these many things, the ICE, the process of finding a device on the internet. So you will need all the information about your device. You will have to have your IP address of the device, public address, your port number, and these are the things. TCP UDP protocol, and that is it. I think these should be the ones. And then, by the way, let me have a look at that again. There are source IP address, destination IP address, source port number, destination port number, and protocol. So just like this, you will have your own IP address, you will have the IP address of the source, the destination. These two things are clear. You will have the port numbers of again, when it comes to IP address, so public and private, both of them are included. Then you will have what you will have port number of the source and destination device, exactly which port you are gonna be like redirecting to or the stream. And lastly, you will have the ID, protocol, whether that's gonna be TCP protocol and that's gonna be UDP protocol. It's just gonna be like that. Let's simply go through it as well. When you create a RTC peer connection object and set up your WebRTC application, your browser will automatically gather information about your PC's identity so that another peer can find you. It's just like that. As soon as you created RTC peer connection, that simply means it got everything. It got the private address, it got public. That's a problem, kind of network issue that I'm facing right now. Alrighty, it turns out that okay, this is fine. I mean, though the network connectivity is bad, but this is fine. In reality, most devices live behind net. And what does this net do? Network address translation. Every device on the web has to have its own IP address. Net allows IP address sharing. Many devices on the LAN, local area network, can share one WAN. So this is the job of net, right? So net is implemented by routers, and routers will create a table mapping the private addresses and public addresses, and that's where net is going to be used. So that's the same thing I'm mentioning over here. Most devices live behind net. That means again router will handle that. WebRTC applications use the ICE framework to overcome the complexities of real-world networking. ICE tries to find again ICE find like that's the framework, and they have there's ICE agent on your device itself, like on the browser, and that will be used for getting the information. ICE tries to find the best path candidate to connect peers. That's gonna be host, or that's gonna be stun, or maybe sometimes that gonna be turn. Every browser has a code in the sense ICE agent that allows it to try and find the best possible routes. That means ICE candidate to your PC. So you will have candidates, and candidates in the sense ICE candidates, and your ICE agent will be responsible for finding that. It will find all those things based on your private address, public address, and port number. That's it. ICE agent operates within the browser's WebRTC implementation. It is integrated into the RTCP peer connection object. So as soon as you just do this particular thing, you implement this, you create a new connection, RTCP peer connection. Your agent gets implemented automatically behind the scene. That simply means it will gather all the information. It will find the best candidate, ICE candidate, and once it got the best candidate, it will just simply make the another user informed about this and all using WebSocket. Let's simply go through it. Process to find on the internet device. Okay, process to find a device on the internet. Collection of ICE candidates. Collection of ICE candidates is referred as gathering phase. So when you are actually collecting all the ICE agents, giving them the giving them some kind of value, because on the level of values only they'll be, so the highest priority, yeah, so giving them some kind of priority so that they can be selected. So collection of ICE and candidates is referred to as gathering phase, and this is triggered by addition to a new M section to the local session description. So as M stands for mainly media, so media, let's make it like this. So as soon as you add a media, at that time that particular ICE agent gets triggered. It creates the ICE candidates and all. You, of course, ICE framework is being used over here. When a new gathering starts, ICE agent will notify RTCP peer connection object that gathering is occurring through a state change event. So ultimately, when the gathering starts in the sense once it has decided, in the gathering phase, once it has actually decided the candidate, and after that you have actually set the media. So once that starts, everything is being set up. At that time, it will inform the RTCP peer connection object that gathering is occurring. So ICE state change event. So over here you will have two things. You will have ICE gathering state. It can be new, it can be gathering, it can be complete. New in the sense right now you have made it new. Gathering in the sense right now it is just simply getting the information of the device and even deciding which candidate to use or not. And lastly, it has complete. Once it actually gets complete, after that there is something like called event listen. So event to listen. So ICE gathering state change, this particular event you will be listening. So ultimately this is how the things are gonna be going on. Let's continue from here on and see what's gonna happen. Alright, so these things I've done so far, and right now I am just simply gonna be watching the video. This is the time going to be to do the things practically. So let's get them done and let's see how it's gonna be going on. By the way, that was it. I'm gonna be catching up soon after I actually create a RTCP connection. Overall things idea I got it. Initially I actually thought that it's gonna be like a nightmare, but it is okay. Even yesterday night my mind was not fully focused on learning, so it's okay, it happens. I'll be back soon, like after watching the video, creating the RTCP connection and all. I'll be back. Okay.
I get up, time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't wanna waste what's left. And on we'll go, through the wastelands, through the highways, till my shadow turns to sun rays. And on we'll go, through the wastelands, through the highways, and on we'll go. Through the highways, till my shadow turns to sun rays.